Hello everyone. In this video, I will be showing you how to build a simple image classification model using TensorFlow. We will be starting by loading and processing our dataset. Then we will build and train a convolution neural network to classify images of Bart and Homer. Who doesn't know Bart and Homer? It's a cartoon series known as Simpsons. So this is Bart and Homer, which are all the characters in this series. Yeah, I thought of classifying something differently instead of cat and dog. So I have used this and find interesting in this project. Yeah. Then we will finally evaluate the model performance after build and train the convolution neural network performance with the accuracy and confusion matrix. Let's get started. So first we have imported all the necessary libraries in the collab file, then extracting the dataset from the zip file to collab here. As you can see, uh, that both test set and train set we got here, and then we have both Bart and Homer images in the both test and train set. Then I just load a image like from the dataset to check if everything's look good of Bart and Homer. Yeah. Then preparing the test data to evaluate our model. As you can see, this is the data augmentation thing we do before training any neural network for image classification problem. So I have used rescale and rotation range. Yeah, the data augmentation thing, right? I have did this, and then se- uh, set has image size 64 into 64 width and height. Then you use batch size 8. Then yeah, then as you can see, the both bot and homer classes denotes, like bot denotes to 0, and we check the classes, and homer denotes to 1. Then we prepare the train test data set also in order to use it later on. Then building a convolution neural network model. So first we created a sequential, um, you know uh, initialize the model. What is do is like initialize the model function that allows use to stack layers one by one. So that's what it do. Like then we add our first convolution layer. This 32 32 filters and 3 into 3 size of matrix. So it this filter helps to detect the future matrix from the images. Then input shape has 64. Our input uh, images are 64 into 64 pixels with three colors channels. Then I have used activation function as ReLU. This introduce non-linearity, allows the network to learn complex features. Uh, yeah. Uh, so and then added our first pooling layer. We reduce the spatial dimension with a max pooling layer. Uh, so with the 2 into 2 window like matrix, um, downsize the image while preserving important feature, and it also reduce computational load. And then I have repeated it to 2 to 3 times because in order to improve accuracy I have did this with two layers, like m- convolution layer, but I got 60%. So I tried now and got accuracy around 90%. So yeah. And then this Then after convolution, convolution and pooling layer, we flatten the output, like flatten converts the 2D future maps into 1D vector, preparing the data for fully connected layer. Then the dense layer, we added two dense layer to perform classification. Three, right? Like end is the output, like we will be getting our you know output has Bart and Homer, right? So we have two. It's a classification problem. Then yeah, so 577 denotes the we need to divide the flatten, how many numbers of flatten divided by 2. We got this number and we set it as the unit. Then activation has ReLU here. At the output we need to classify two uh, you know images, like if the image is Bart or Homer. Yeah, then I have used softmax here. This converts the output into probabilistic, making it suitable for classification problem. So this is the summary of our model. Then I have used Adam or optimizer, um, you know for optimizer, and set the training set has epoch has 50. Then trained our model and plotted the validation loss and validation accuracy. As you can see, like after 50 epoch, uh, as you can see, like from the 0 to 50 epoch, the validation accuracy is improving to 90% at the 50 epoch. Yeah, then we have used the model in the you know test data set, and we got the result. When we plotted, when we checked the accuracy, we got 90%. Then when we plotted, as you can see, for bot images it has been classified, 27 images correctly out of 28, and then Homer images has 22 images was correctly classified and 4 was not correct. um, as you can see, it is giving high accuracy for classifying the you know bot. 0 denotes to bots, right? Yeah, then 80%, but it precisely good model of, like, to classify bot and Homer images. Then we load our model uh, here in the collab file, and then used it for uh, then using this weight file to check whether the image is a bot or a Homer. As you can see here, if we just give the image and use this classify image function, we will be getting prediction, the image and the prediction Homer or bot. As you can see, this is Homer image and we got the prediction as Homer from the model which we have used here. And then this is the bot image. We can recheck it for another image, like, just a minute. It doesn't classify because uh, you know uh, it the prediction was wrong because of it. The bot has been covered his head and eyes. As you can see, those were the main features which was useful for detection. If I change for bot, yeah, if you can see here, eyes and hair, yeah, bot. So that's it for today. Thanks for watching.